Okay, now members, let us see crossing a river problems. So when we are handling problems of crossing the river, we assume that the river banks are parallel. So it's that the river banks, this is our river. So these banks, we consider them to be parallel, as simple as that. So don't assume these rivers, when which are bending, Oxbow and so on. No, we assume that they are parallel. Case 1, crossing a river from a point A on a bank to a point B directly opposite to A on the other bank. So you want to cross from here up to here. So in simple terms, this is what we call covering crossing the river with the shortest distance. So this is when we cover it in the shortest distance. So because the water is going to be flowing, remember water is flowing in this direction. So meaning you have to set a course in this direction so that the flow of water is pulling you, is pushing you to where you want to be. If you set the course direction to this, you end up on the other side of the point you want to get. So that's why whenever you want to cross a point directly opposite to where you are, if you are here and want to go here, you always set a course going this side, because this water, as this water is coming, is going to be affecting the direction of that boat. So after all, you are going to find yourself like this. So if you want to go directly opposite the point, you set a course. We always set the course to the bank, going this side. And then this water will be able to put you in the exact direction as you want. So when you want to go the point directly to the where we are, this is always going to be our resultant. VW is the velocity of water. Of course, the river is having water. So the velocity at which this water is moving is VR. Then this is the velocity of the boat or swimmer. As you see there, so if you want to get, you know that if we have cos theta, it's going to be adjacent over hypotenuse. This is our hypotenuse, so that this one is going to form a right angle triangle here if you complete it. And you want to complete so that you can see that this is the velocity of water. And so sin theta, so if you want to get the resultant, you get dB cos theta. If you want to get the velocity of water, if you don't have it, you get dB sin theta. But note, the cos always we say is this alpha. Take note. So this is the boat crossing the river in the shortest distance. You see that this one is going to be a shorter distance to cross, because the resultant is what we are going to be using there. And let's go to case 2, crossing a river in the shortest time. Crossing river in the shortest distance is different from crossing the river in the shortest time possible. So take note. Now, if we want to cross the river in the shortest time possible, it means that we should be able to use the flow of the river. So if I want to cross from maybe, and this one is the case where we also have, this one is called the downstream and this one is called the upper stream, if we are basing on these two, A and B. Downstream, upstream. Where water is coming from, we call it the upstream. Where water is going, we call it the downstream. So if I want to cross in the shortest time possible, it means that I should be setting in the direction of that water. I started the example here. Remember, when we are going up this side, you are going to receive a bit more resistance than when we are going down in the direction of water. I said our resultant here is going the other direction to the flow of the water. So meaning here, the boat we reach earlier, the speed here is going to be very, very much than the speed when we are going the other side up. So whenever I want the shortest time possible, we set our course to this direction where we are, but down the stream. From there you can see if you want this, you said we are going to put right angle triangle. If I want this, I get this square plus this square, then I get a square root. Time taken to cross the river, remember this is the distance AB. So I'm getting distance AB over the velocity I'm using, the velocity of the boat I'm using there. That will be the time. Distance must be downstream. So remember, you are from this point, so it's like exactly opposite to this one. So meaning the distance moved downstream is here up to here. So what does it mean? It means that I'm going to get the time I take to cross, then time with the velocity at which this, because this is the velocity, that which is pushing me to the other side. So you get VW, the velocity of the water, then times the time. Time theta is equal to VW over PB. Crossing the river upstream, here you are experiencing a lot of resistance because you are going opposite to the direction of the flow of the river. So that's why if I want now to go upstream, if this is the AB, we said upstream is this side. So if I want to go to this point, now I should set a course to this bank. But you see that, I think we saw difference. Here, we are our velocities in relation to that, the way we want to go. But here, we are just wanted to cross in a shorter. So always this one is always at a distance. If you want the shortest distance, the result should be straight there. Then this one is at our result, because we want to go at a point from where we are. So that's why it's that we are pushing a little bit to the side. So there are velocity, velocity. We shall add the velocity of the boat plus the velocity of the flow. In most cases, some people call this current. If you want their current, it's okay. Maybe just wanted to use water because everyone knows the river has water current. People may think it's electricity. Anyway, note this is upstream, this is downstream. Because to use alpha is always set to the bank of the river. So this is the course always we use. When we are touring, we always set that course in relation to the bank of the river. So that's it. I wish you well.